All right, so section 5.7. The good news is that 5.7 is essentially a review of 3.7. I think it's 3.7. It's looking at inverses again. Just this time, we've seen the functions now. We know what they look like. We can kind of predict when and where they're going to have domain issues. And so we're going to revisit this idea of inverses, but we're going to do it without drawing graphs. So, inverses, radical functions, mostly looking at parabolas here. Okay, we have to restrict the domain to make sure that we end up with a function. So that means in order to do an inverse, remember we have to have passing the vertical line test to be a function, and then pass the horizontal line test in order to be one-to-one. If it's not one-to-one, I can't find the inverse. So that's where restricting the domain comes in. So if we just look at these, okay, 5x cubed plus 1. Well, the good thing is it's a cubic function, and cubic functions have a very particular shape. They'll end up looking something like that around an axis somewhere. What that means for us is I don't have to restrict anything. It is a function. It is one-to-one. I don't have to do any work. So my original domain is all real numbers. My original range is all real numbers. And what that means for us is that I can just find the inverse. So to find an inverse, we swap x and y. We subtract 1, so x minus 1 is 5y cubed. Divide by 5, so y cubed is x minus 1 divided by 5. Take a cube root of both sides, and that means that our inverse is the cube root of x minus 1 over 5. Okay, the other thing they want you to remember is if I can find the domain and range of the original function, then I already know the domain and range of our new function. Okay, the domain of the inverse is the range of the original function, so negative infinity to infinity. Okay, and the range of the inverse is the domain of the original. And I know this is not the greatest example of that because both of them are all real numbers, but it's what we've got. So we're just going to remember that's the thing. Okay. Then we go back to our next one. So f of x is the cube root of x minus 5. Now, if the cube of a function doesn't have anything in it that's going to cause it to break, I don't have any domain issues, then the cube root also doesn't have any domain issues. So my original domain is all real numbers. My original range is also all real numbers. And we just find the inverse the same way we did the other way. So swap our x and y's. To get rid of the cube root, we're going to cube both sides. So x cubed equals y minus 5. So y is x cubed plus 5, which means our inverse function is x cubed plus 5. And again, our domain for the inverse is the same as the range of the original, and the range of the inverse is the same as the domain of the original. Okay, so no restrictions on the domain, nothing to worry about, no real problem here. But what happens if I work with a parabola? So if f of x is x minus 1 squared. Well, we know a parabola has a really distinct shape. We know it looks something like this. So we know it's going to pass the vertical line test, but the second that I try to do a horizontal line test, it fails. And hopefully you remember our remedy for this is, let's just work on the right side. And then if I really need information about the left side, I can just use the properties of symmetry and kind of transfer it over. Awesome, okay? So what I need to do is find the vertex and then look at just the right side. So anytime you see a parabola, you need to start with, where is my vertex? Now this one nicely is in vertex form. Remember, this is x minus h squared plus k, and our vertex is the h value and the k value. So this is plus 0. So my vertex is at 1, 0. So that tells me a lot of things. First of all, it tells me that when I restrict my domain, I need to restrict it from the vertex to the right. So I'm going to go from 1 to infinity. The a value out here is a positive 1, so it's positive, which means this faces upwards. And so the range of my original function is going to be 0 to infinity. Good to know. Then I'm going to go and find my inverse. So x is y minus 1 squared. I'm going to take a square root of both sides. I'm going to add 1 to each side. So y is the square root of x plus 1. And that is our inverse. Let me write that just a little bit easy, okay? Then I have to look at, what is my domain and range? I have this inverse. What is the domain and range of my inverse? Well, the domain is equal to the range of the original. So my domain is 0 to infinity. My range is going to be 1 to infinity. So again, they swap places, but accomplish the same thing. Okay? Anytime you have a parabola, find the vertex. That will tell you your original domain and range. Then find the inverse, and when you do the domain and range of the inverse, just copy the information from the original. Don't think about it too hard. Don't worry about it too much. Copy what you have in the opposite order. All right, last one on this slide. I've got another parabola. F of x is 10 minus x squared. Now I'm going to rewrite this to make it negative x squared plus 10. This is still in vertex form. I know it doesn't really look like it, but it does. If I rewrite this as negative 1 times x minus 0 squared plus 10. Now it's in vertex form. Now that looks familiar. All right, so if that's familiar, then our domain, well, let me back up. Our vertex is going to be at 0, 10. My domain is going to go from the vertex to infinity. And then for range, I need to know what direction it's facing. So this case, A is negative, which means that this has that cap shape. It's upside down. So my range is actually going to go from negative infinity up to the y value of the vertex. Sorry, it's going to include the y value of the vertex. Now I have enough information on my original function. I've restricted the domain, so I can go back and now I can find the actual inverse. So x equals 10 minus y squared. So x minus 10 is negative y squared. Divide by negative 1, so negative x plus 10 equals y squared. Take a square root of both sides. So my inverse is the square root of negative x plus 10. Now, if I want to find the domain and range, don't think about it. My domain is the range of the original function, so negative infinity to 10. My range is the domain of the original function, so 0 to infinity. All right, so I'm not going to go through all of the examples on this slide because I did the domain of the inverse on the last set, so I don't want to like repeat everything. But I encourage you to try them. Try them and see what you got. I will do the first one just to remind you of the little trick you can use to get this to work. So x minus 2 over x plus 4. Now, I'm also going to show you how to find the domain and range of this particular function. You are welcome to use Desmos to do this because we haven't covered it yet. You are welcome to use Desmos for this particular application, but in 5.6 we talked about asymptotes, we talked about where they come from, how to find them. So their vertical asymptote is where x plus 4 cannot be 0, so x is negative 4. Our horizontal asymptote, we're going to take the biggest term out of the top, biggest term out of the bottom, and simplify that. So our horizontal asymptote is at y equals 1. Why do I care about the asymptotes? Well, this is why. My domain is everywhere except the vertical asymptote. So negative infinity to negative 4 union negative 4 to positive infinity. My range is everywhere except the horizontal asymptote. So negative infinity to 1 union 1 to infinity. Now that I have that, let's look at the inverse. So inverse of a rational function, x equals y minus 2 over y plus 4. We cross multiply, so x times y plus 4 equals y minus 2. xy plus 4x equals y minus 2. Now anything with a y in it goes to the left, everything else goes to the right. So xy minus y is negative 4x minus 2. Then we're going to factor the y out of each of these terms. So y times x minus 1 is negative 4x minus 2. I'm out of space down here, so I'm going to move up to the top. I'm going to divide both sides by x minus 1. So negative 4x minus 2 over x minus 1. So my inverse is negative 4x minus 2 over x minus 1. Now, to find the asymptotes for this function, to find our domain, I could do all of that process that I did before all over again, or I can just rely on the fact that the range of the original function is the domain of the inverse. So my domain is negative infinity to 1 and 1 to infinity. My range is negative infinity to negative 4 and negative 4 to infinity. Okay, so it's all about kind of capitalizing on, I wouldn't call them shortcuts, but capitalizing on those properties so that you don't have to do as much work